Hi, everyone. Thank you for signing up. Can everyone hear? Okay, great. Thanks for your time. It'll be real short and quick. Today we're going to talk about one new product that Evertz has brought up, Media Flow. I'll give you a good background about it. All media companies normally face a problem of bringing up all the streams, ingesting them, and processing to the cloud. It's like the example is from various providers. The example could be the streams are different structure, they have different bit structure, they have different encoding, audio, video, and stuff like that. So to normalize those streams and process them in the cloud this is where media flow comes into picture. So the animation doesn't work for some reason. Anyways. So here are a quick summary of features that media flow offers. As I mentioned, it's an integrated solution. I would explain what integrated solution means later on for simplifying operational workflows of onboarding and normalizing audio video workflows for broadcasting solutions. So you can do PID muxing, PID remapping. So whatever I talk about this product, this is all within the compressed domain. We do not go back to baseband or decode it and re-encode. So that saves a lot of hardware and time and effort. So you can do closed captioning insertion on this platform within the compressed domain, which is kind of interesting. SCARI35 insertion for your downstream dynamic ad insertion workflows. Lip sync correction, if there is any lip sync, your user finds there is any lip sync, audio video lip sync, you can adjust it. Audio processing, transcoding, you can go Dolby E to AAC or MPEG-1 layer to any kind of cross conversion of audio codecs can be achieved without going to baseband. Up-down cross conversion, this definitely needs a hardware acceleration. This is where, when I mentioned integrated solution, this is where we go out of software domain, we add another component, which is hardware. I'll show you what that product is. Stream delay, you can add up to 10 minutes of transport stream delay if it is encoded at 10 Mbps. Then tier 101 to 90 monitoring for any kind of issues with the transport stream. It can raise a flag. And then we have an automated solution where you can either fail over to another stream or the user can intervene to take the corrective actions. Frame synchronization, this again needs a hardware component. So this is the broader architecture of media flow. As you see, the green box in the middle is what the software component is that I just mentioned. And the blue next to it is 5-second ITX. This is where when you need to do some hardware intensive processing, you need this component. So we talk about the green box in detail. So you might not be able to read all this, so I just put some of these call outs. So the first block is transport stream monitoring, time code insertion, input delay, audio decode, recode. I mean, you can have maybe 10 audios in a stream. You can drop or you can re-encode to a different audio codec. PID remap, this is very interesting. This is where when we say the audio streams are normalized for a very deterministic output for OTT workflows, where normally there is one video and two audios AAC, and the downstream devices expect a fixed set of PIDs. So if the input PID is changed, the output would automatically be set to the one which is required by the downstream devices. This is all automatic. Closed captioning insertion or bridging, if you want to add another data PID, that can be done. If you want to insert like or using a telnet, you can insert captions as well in the compressed stream. And SCARI35 insertion. So as a result, you get a smaller infrastructure because you don't need to add many hardware components because you remain within the compressed domain, be it MPEG-2, MPEG-4, HEVC. It's codec agnostic. Quick time to market, and you save some money as well. This is where I was talking about the other part of this integrated solution where when we talk about up-down conversion or frame sync kind of functions, this product that goes with the media flow It's one input with simultaneous multiple output, which means it can take an IP 2022-6 or 2110 or SDI or ASI over IP, either one of them. And it has a bunch of processing, frame sync, mux sync, UDX, and all those components that are available in the compressed domain as well. It can give you SDI, it can give you MPEG-2, it can give you J2K for contribution, distribution at the same time, XDCAM for your file archive. So everything is available simultaneous. It's, we have deployed it. This is like one of the most sold product in our product portfolio. More than 1,500 channels in production. This is the whole media flow where I say that the middle server is a software component, and then at the bottom there is an IP switch, which is again Evertz switch. The bottom left is the ITXC, which I was talking about. And then if you want to do frame FEC to the streams, you can use the 570 forward error correction on the streams. So we did a very interesting show, IBC this year. So this is what we showed live. We ingested, there was a camera on-prem at the IBC show floor. We encoded it on-prem using our own encoder and pushed it using SRT on public internet to Google Cloud in Amsterdam in a container. So all this, the media flow, this product is containerized. You can fire up in any virtualized environment. It's a Docker container ready. As you can see, the Docker container, on top of it, there's a Kubernetes which manages the container orchestration. In Kubernetes, we have those three management tools, CSM, IRM, and Etiquette. They work in tandem. Like Etiquette is the one which is kind of license manager. So this, the first instance was in Netherlands, where we pushed in 10 Mbps of MPEG-4 stream, and it came to Montreal, like East Coast Google Cloud, through Google backplane. Google has its own backplane. They don't go back to public internet. That's why they are faster than other clouds. And we brought it to our Evertz headquarters in Burlington, did some reprocessing, logo insertion and stuff like that, and sent it back to Netherlands through the same path. Encode, decode, across continent travel, everything was 1.3 seconds. This was the fastest, what we are trying to present here. So the use case is you're sitting somewhere here in LA and you want to ingest a stream in Japan, a sporting event comes up. You just need to fire an instance in Japan or maybe wherever the nearest Google node is, and you can bring it here in the fastest possible way. All right? So, sorry. So this was the live video. I don't know if it's going to play. Sorry, it's not playing. So this is the management part of the product, where, as you can see on the right-hand side, there are different kind of containers we talk about, and one of them is our media flow container. So we have Kubernetes as an orchestration. EV Edge is another microservices-based Evertz solution for managing your containerized product offerings. On top of it, there is Etiquette, as I mentioned, as a license manager. CSM is compression system management, which basically deals with all the redundancy requirements. So if one container dies away, it automatically senses it and fires it up. And on top of it, everything, there is a big data analytics tool inside, which harvests all the data from all end devices, be it our Evertz products or any third party. And it does intelligent decisions and tell the system, CSM, if something is going wrong with a particular container to fire up another one. So it's all automatic workflow. This is the user interface of View, which sits on top of all these management tools. It's a very customizable interface, which basically tells you if anything is wrong with a particular container, the user can intervene and take corrective actions. But this one is not only your configuration, it does your monitoring as well. On the left-hand side, as you can see, there is a penalty box. It tells that these three services have some kind of issues. You click on that, it comes up, and you understand where in the whole path something is wrong with that path, and then you can go inside. So we talk about just one product, media flow, but that doesn't mean we don't have any other products. So we have a whole very rich compression product line, which we can talk about. If you talk about any platform, we can run on any platform, modular, server-based, or software-defined in the cloud. So what does it do? Sorry, the formatting is changed. Delivers broadcasting quality video from, the question is where from? We can take from any source, camera, player, or streaming devices, over any network, SDN network, IP 2022-6, 2110, satellite, to any device, TV, set-top box, PCs, or any other mobile handheld devices. So we can deliver to any end device. Format, any format you name, like these are pretty standard. You see these days STH, GHT, or ABR delivery as well. Codec, we have all these codecs, J2K, MPEG-2, H.264 for HEVC, and even the newer coming AV1 as well. It runs on Evertz proprietary hardware. The same time it's server-based as well, where you can have different kind of even some services need for higher density, you need accelerator cards for higher density, but some of them runs on COTS. They are containerized as well, runs in the cloud, public cloud, private cloud, or even hybrid cloud, where some services need to be, like you cloud burst them into the cloud if the requirement is coming. Result, most flexible, scalable, innovative, and cost-effective solution. This is the market segments that our product lines can cover: contribution, distribution, primary distribution, processing, and secondary distribution. Hardware devices we can run on. That was very quick. Questions, sir?
Caught me off guard there. Okay, we want to get these on our video. So if we got questions, we got a microphone. Take it away.
Yes, in the first example that you had showed where you encoded and uploaded the video to
Sorry, let me go back
Montreal.
to that slide. This one?
Yeah, from Netherlands all the way to Montreal.
Yeah.
And what was that encoding delay at the source?
The end-to-end delay, encode, going from Montreal to, Netherlands to Montreal and back, and decode, it was 1.36 seconds, which included encoding, decoding, as well as going across the continents.
Okay.
Yeah, and it was over public internet, I must mention. From IBC show floor to the cloud, it was public internet. DSL line, 100 Mbps, but we are using only 6 Mbps of video, H.264.
Okay,
Thank you.
We have another question here. We've got plenty of time. Who's got a question? Oh, I think, are we done early? Do you have anything else you'd like to cover?
I gave them 5 minutes back.
Give it back. That's very generous of you. All right, so we have one other thing to give them. If you want to read the top name, we have someone is going to win this mug and golf shirt. Who was our winner?
Is there any Terry Wall?
Terry? All right, Terry, come on
please
up.
come.
Hope you're large. All right, thank you, everybody. And big round of applause. That was fantastic. And we will be back for our last session of the day at 4:25.